Alright guys, in this video we're going to be introduced to the Pythagorean Theorem, and I'm going to be telling you guys what it's all about. Alright, so let me start off with a right angle triangle. Alright, so in a right angle triangle, or in any triangle, there is obviously three sides. Let's call this side C. Oops. Let's call this side C. Let's call this side A, and let's call this side B. Alright, so the Pythagorean theorem says that if you take the side C and square it, it should equal to the sum of the other two sides squared. So it should equal to A squared plus plus B squared. Alright, so you might be wondering how can you square a triangle and stuff like this. I'll try and make my drawing as best as possible, but no promises. Basically, this equation is basically saying that if you square this side of the triangle, so let me just move it up, square this side in a way that the dimensions from here are the same as here, here, and here. Let me just get rid of those lines. And if you square this side, that looks like a decent square. And if you square this side, the areas of these two squares, so these ones, should equal to the area of this square. Alright, so times that you would need to use this equation is when basically when you are trying to find one side of a triangle. Alright, so let me just get rid of this real quick. Alright, so say you were trying to look for the hypotenuse in a triangle. The hypotenuse is always the longest side. It is the side right here, the side that is opposite to the 90-degree angle. Alright, so say you are looking for this side right here, and let's just call it C for the sake of the the formula. And let's say this side is a 6 and this side is a 7. Right off the bat, you know that this longer side C, the length of that side has to be greater than 7 because the hypotenuse is the longest side in the triangle. Alright, so let's start off with the equation. The equation, it says that C squared is equal to A squared plus B squared. Alright, so we don't know what C squared is, so we have to keep that. A squared, it's going to be 6 squared, so 6 squared plus B squared, which is 7 squared. I'm picking numbers right off the bat that we know we could square off our heads, right? So C squared is equal to 36, and 7 squared is equal to 49. Alright, so something to know here is that the question is looking for the side length, obviously, so we cannot just leave it at C squared. Once we add 49 and 36, we can't just leave it at 85 because obviously right off the bat you could tell that's a little weird since the side lengths are 7, 6, and then you have 185 after. That doesn't really make sense. Alright, so now what you're trying to do basically is get rid of this square right here. In order to do that, I'll make it a little larger. In order to do that, you have to square root both sides, right? So on the left side of the equation, right here, let me pick a different color. The square root cancels because once you square something and square root it, example, if you have 7 and you're square rooting, if you're squaring and square rooting it, you go to 7 squared is 49, and then square root it is back to 7. So it basically cancels each other out. Example, square right here, that's just going to give you 49, and then square root of 49 is just going to give you 7. So you ended up back with what you have. So you might as well just cancel all of that. Saves you a lot of time. Alright, so once we square both sides, we're left with C alone. But then right here, we have the square root of 85, so we would have to use a calculator for that. you use square root of 85. It gives you 9.22. So always put the dot on top of the equal sign to signify that it is a estimate, not an estimate, sorry, an approximation. Alright, so now you know that the side C is 9.22. Alright, so the Pythagorean theorem is not only used to find the longest side of the triangle, which is the hypotenuse. It could also be used to find the other side of the triangle as well, which I will show you in a moment. Alright, so make this a little larger. Alright, so after we just found that the other side of the triangle is 9.2, I'm just going to round it up to, I'm going to round it down to 9 point, just 9, sorry, because it'll just make our calculations a lot easier. Now let's try and look for this side right here. Let's call this A, in the sake of the formula, and let's call the hypotenuse a 9. All right, so now we have c squared equal to a squared plus b squared. All right, so I'm gonna underline what we know. We know what c squared is. It's gonna be 9 squared, and we know what b squared is, right? So now we have to isolate for a squared. So in order to do that, we have to keep a squared on this side, and then c squared is already on the other side, so it's c squared. But we have to move b squared to the other side, and while you're moving b squared, instead of going from plus b squared, you go to minus b squared. All right, so now this is a formula that you're going to be using now. All right, so we don't have a squared, so let's keep a squared here. C squared is going to be 9 squared minus b squared, which is 7 squared. So it's going to be a squared is equal to 9 squared is 81, 7 squared is 49. I'll go my calculator. 81. Oops. 32. All right. So let me scroll a little down. Just like before, once you have a square and you're trying to get rid of it, you're trying to square root it. So these two, oops, 1 second. These two cancel out, and in order to square root one side, you have to do the same for the other side. So just going right here, the square root cancels because you're squaring it, so it's pointless. And a is simply equals to the square root of 32, which I will do right now. Square root of 32. It's going to be 5.66. This does make sense because if you think about it, we did start with a as a 6, right? And we ended up with a 5.66. The reason we didn't end up closer to 6 is because the c, which is the hypotenuse, was 9.22, I believe, and we rounded down to 9, so it makes sense that our answer for the side A is a bit shorter. Alright, so say you wanted to solve for the side B now. Alright, so let me erase this. Let's call this a 6, because that's where it is. We'll erase this. Let's just say this is a 9. And let's call this a B. Alright, so just like before, you can manipulate the formula to change it to what we are solving for. So c squared is equal to a squared plus b squared. This is the original formula. But just like in any formula, you can move variables around in a legal way that the formula still makes sense, and you could apply it in a way that you will receive the correct answer. Alright, so I'm going to underline in a different color what we do know. We know what c squared is, and we know what a squared is, but we don't know what b squared is, right? So we have to keep b squared on one side. So this is the side b squared is on, but we have to move a squared, to the other side. And in order to do that, turn from a positive a squared to a negative a squared. So the formula that you would want to use is b squared is equal to c squared minus a squared. Alright, so let me just apply this real quick. B squared is equal to c squared would be 9 squared minus a squared, which is 6 squared. B squared is equal to 81 minus 36. I'm going to pull out the calculator. You get 45. B squared is equal to 45. Just like in all the other equations, you have to square root both sides. Oops, By doing this, you cancel out the square on the b, so you are left with b just alone, and that is exactly what you want. And you get the square root of 45. If everything goes well, this should be very, very close to 7. Maybe like a 6.7, I'd say. Square root of 45. Yep, exactly, 6.71. Alright, so let's copy this down. 6.71. Just like before, this isn't exact because we rounded down from 9, and we rounded a bit up from 6, I believe, so the answer is not going to be exactly 7, which we could tell already that we did it correctly because it's very close to 7. Alright, so a quick summary: the Pythagorean theorem is basically used in right angle triangles to find out the missing side. So it could be to find basically just about any side. It could be to find the hypotenuse, it could be to find the b side or the a side, whichever you're comfortable with, and it could be find for the other side also. Alright, thank you guys for watching, and I hope I helped you guys.